Look at this comet! Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the Sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. They erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the Sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the Sun's light. The cloud that forms around the comet is called the coma, and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the Sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the Sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the Sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsuchinsan Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transition from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe, around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase, or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out.
The very first known interstellar object, or ISO, to pay a visit to our solar system was a rocky, elongated interloper with a slightly reddish hue. It was spotted in 2017 and was dubbed with the Hawaiian name Oumuamua. It was almost 10 times as long as it was wide, and it was extremely unusual. Objects in our solar system are rarely shaped this way, so astronomers hoped it could provide some clues into how other star systems form and function. For hundreds of millions of years, longer than I've been around, this bizarre guest has been wandering through our home Milky Way galaxy, not bothering to settle down in some star system. And then, it came across the solar system. After the space traveler was discovered, hundreds and probably even thousands of telescopes all over the world, including ESO's Very Large Telescope in Chile, sprang into action. They started measuring the object's orbit, its color, and brightness. That's when it became apparent that the space rock had an unusual orbit. Some astronomers suggested that Oumuamua was emitting hydrogen it had picked up during its journey between stars. This was a simple explanation for the mystery that had evoked lots of outlandish theories. When this bizarre guest was first spotted upon entering the solar system, scientists were not sure what its nature was. Some claimed it was a comet. Others disagreed, saying it didn't have the features typical for comets: a visible long tail and a coma, which is a cloud of gases surrounding the nucleus of a comet. Plus, its shape was different from that of other comets. The only thing that made Oumuamua more comet-like was the way it accelerated as it went away from the sun. The unusual object started to slow down on its way out, but in a strange way, as if not only gravity was in play there. It seemed like something was creating a force to counter this gravity. But unfortunately, this theory didn't quite fit either. The problem is that comets usually have large quantities of water ice on their surface, and as the sun heats this ice, it gets ejected as jets of gas. Those jets act as mini rocket boosters. But Oumuamua not only had no tail whatsoever, but it was also too small to capture enough solar energy to support this kind of activity. Of course, this mysterious space visitor caused some more outlandish theories. For example, some people started to claim that Oumuamua could be a spacecraft sent by a civilization living in another star system. However, scientists found a better explanation. A comet that is traveling between stars gets cooked by cosmic radiation. These rays penetrate thick layers of ice, converting up to 25% of water molecules into molecules of hydrogen. And then, this trapped hydrogen gets released when some star warms the comet. The effects of this process are almost invisible. This might be the reason why we didn't see a spectacular tail accompanying Oumuamua. At the same time, the potential comet was so small that this could produce enough force to power its acceleration. As for the amount of ice released as Oumuamua was coming closer to the sun, it was likely too small for astronomers to spot it. Now, even though Oumuamua was the first known interstellar object to enter our solar system, it wasn't the last. In August 2019, comet 2I Borisov visited us, becoming the second ISO astronomers managed to spot. Now, no one can argue that there simply must be more visitors from faraway star systems than those two. ISOs are rare, but our solar system is pretty old. It must have been capturing some interstellar travelers over the millions and millions of years of its existence, even though they never stayed for very long. One study has taken a closer look at interstellar objects, and they concluded that these space travelers might be caught not in solar orbits, but in near-Earth orbits. The astronomers working on this project even go as far as to claim that there might be a lot of ISOs in orbit around Earth. Now, finding tiny objects in the vastness of the cosmos is extremely tricky. Think about it. What images of distant areas of space do we usually get? Mostly stars. Sometimes unclear pictures of exoplanets. Even more rarely, it can be disks of debris. But fine detail in small space objects? Almost never. So it's actually lucky for us that other solar systems send their inhabitants to visit us. Because by studying ISOs, we gain insight into the formation, evolution, and functioning of other star systems. Have you ever heard of the Oort Cloud? It's the most distant region of our solar system, and it's quite unusual. You see, the orbits of the planets lie mostly in the same flat disk surrounding the Sun. But the Oort Cloud is believed to resemble a spherical shell surrounding the entire solar system. It looks like a gigantic, thick-walled bubble made up of chunks of ice and other space debris as large as mountains or even bigger. Astronomers think that the Oort Cloud contains billions, if not trillions, of different objects. There might also be a connection between the Oort Cloud and ISOs. Because scientists think that interstellar objects might outnumber those from the solar system in this region. Even though no one has ever observed the Oort Cloud directly, astronomers are sure it does exist. They made such a conclusion after observing the distribution of comets in our solar system. The Oort Cloud could have formed from debris in the early solar system, but some experts argue that the largest part of this unusual shell could be interstellar in origin. If travelers from other star systems are as common as some studies suggest, lots of the bodies on the edges of the solar system are likely to have originated in other systems. Sadly, this theory hasn't been proven yet. Now, since we've been talking about comets, not Cupid or Donder or Blitzen, one of them has recently approached the Sun at breakneck speed. It was 96P Machholz 1. This comet is around 3.7 miles wide, and astronomers think it might have arrived from outside the solar system. The NASA European Space Agency Solar and Heliospheric Observatory spacecraft has been monitoring the comet. So look at this. That's the comet's tail. It's mostly made up of gas. It's trickling behind frozen chunks of ice that are getting heated by the radiation coming from the Sun. In some cases, a comet can have two tails, one made of dust and the other consisting of gas, and each of them can reach hundreds and, in some extreme situations, even millions of miles in length. In 2008, scientists analyzed the material left by 150 comets. They found out that the comet we're talking about was quite low in carbon and didn't contain a large enough amount of some other typical materials. This could only mean one thing. The comet was an interloper coming from another star system. It may have been ejected from its original solar system by the gravity of a large planet. After that, the poor homeless thing probably spent a large amount of time wandering around space, until it came across Jupiter. The gas giant could have bent the comet's trajectory, trapping it in orbit around the Sun. There's one more theory. According to it, the comet formed in a poorly studied region of the solar system, and it has this weird composition due to its repeated journeys around the Sun. Now, scientists are watching the comet with anticipation, like Christmas. Since it's an atypical one, both in its behavior and composition, they don't know what they will see, which makes the whole process even more exciting. Most comets falling toward the Sun are quite small, not more than 32 feet across. That's why they burn up as soon as they come close to our star. But the sheer size of Machholz 1, which is more than 2/3 the height of Mount Everest, seems to protect the comet from evaporating completely. Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, It could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Boötes Void in the constellation of Boötes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boötes Void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, These stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space: thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow.
At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. Only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard Worlds Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across two black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri E, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, the year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri E had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Cancri E might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Cancri E, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pole star, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pole star in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where two massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets, like Oort 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tres 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve as a reminder of how much we have yet to learn about the universe.
Picture a silent ember drifting toward the sun, moving so quickly that no gravity well in our system can bind it. That ember, provisionally tagged 3I Atlas, appeared in late June when the Atlas Hazard Survey cameras in Hawaii and South Africa logged a faint, fast intruder. Initial orbital fits showed an eccentricity greater than 1, the mathematical stamp of an origin beyond the sun's reach. We have met only 2 such emissaries before, 1I Oumuamua in 2017 and 2I Borisov in 2019. Now a third arrives, tugging at our curiosity and our instruments in equal measure. The object's present speed is almost 70 kilometers per second, enough to span New York to London in 90 seconds. Backtracing the path leads toward the constellation Lyra. Forward projection shows a swing past Mars on 3rd October 2025, a solar perihelion 20 days later at twice Earth's distance, and final escape by early 2026. Earth stays on the sun's far side throughout, so the risk ledger reads 0. The intrigue ledger, however, is packed. Composition sits at the top of the to-do list. A comet would sprout a gaseous veil as ice evaporates, yet deep imaging has yet to reveal any coma. An asteroid would follow purely gravitational curves, yet a whisper of extra thrust may lurk in the astrometry. The James Webb Space Telescope can cut through reflected sunlight and sample the infrared glow for water, carbon monoxide, or exotic minerals. If the spectrum comes back featureless or metallic, theories multiply. Brightness fuels the puzzle. Even with a modest albedo, the observed flux implies a body several kilometers wide, far larger than Oumuamua, whose size was measured in hundreds of meters. A highly reflective hull could achieve the same luminosity with far less mass, a possibility that keeps technosignature specialists awake. Professor Avi Loeb, already known for suggesting an artificial origin for Oumuamua, is lobbying for continuous JWST tracking to test for non-gravitational acceleration. A persistent drift unaccounted for by gravity would demand explanations that push against the boundaries of conventional astrophysics. Statistics pose the second riddle. For centuries, astronomy recorded 0 interstellar passers-by. Now we count 3 in 8 years. Better sky coverage explains part of the surge, yet simulations indicate the detection rate is still high. Either the density of galactic debris is underestimated, or transient swarms are sweeping the sun's neighborhood. The Vera C. Rubin Observatory, starting full operations next year, will clarify the odds by mapping every moving speck down to faint magnitudes every few nights. Structure forms the third unknown. Light curve monitoring can reveal whether 3I spins like a platter, a spindle, or a rubble pile loosely bound by microgravity. Oumuamua's flattened shape and unexplained kick remain controversial. A repeat would strengthen calls for new physics or new engineering. Rapid tumbling might indicate past collisions, freshly exposed ice, or even deliberate attitude control. That opportunity extends well beyond the object itself. Each interstellar visitor carries isotopic fingerprints of the chemistry that shaped alien worlds. Sampling those fingerprints, even remotely, refines models of planet formation, volatile delivery, and the migration histories of giant planets. In a decade, robotic missions may be fast enough to intercept such bodies. Today, we practice with photons. Time is tight. By September 2025, the object will vanish into solar glare. By the time it re-emerges, the outbound leg will dim below major telescope thresholds. Roughly 5 months remain for the most ambitious observations. Teams are coordinating radar pings, ultraviolet spectra, and high-cadence photometry to squeeze every bit of information from the fleeting visitor. Why should the broader public care? Because 3I Atlas is a tangible reminder that our solar system is not an island, but a crossroads. Somewhere an unknown star flung this body into the dark, perhaps through a near miss with a giant planet, perhaps through a cataclysmic collapse of a binary pair. After wandering for millions of years, it has brushed past our doorstep, offering a message in a bottle. The galaxy is bustling, and we are part of that bustle. Whether the newcomer proves to be ice, rock, metal, or something unprecedented, its brief appearance renews a sense of frontier. Sky surveys sharpen, theories adapt, curiosity deepens. The next discovery may come sooner than anyone expects, and when it does, the groundwork laid today will allow us to read its story more clearly. For now, astronomers chase a streak of light across CCD frames, and every clear night might deliver a clue that rewrites chapters on planetary science, or adds a footnote to the search for artifacts among the stars. In either case, the sky is not done surprising us. Origin scenarios abound. Some simulations eject 3I from a nascent planetary system after a close brush with a giant planet, while others invoke a crowded stellar nursery where passing stars fling debris across interstellar lanes. Whatever the trigger, the body has drifted for perhaps tens of millions of years, carrying the isotopic signature of an alien chemistry lab. Radio arrays will also listen for narrow-band emissions, more out of thoroughness than expectation. After Oumuamua, techno-signature protocols are standard. Scan, archive, move on, unless a signal repeats. Looking ahead, Rubin's legacy survey of space and time should uncover several interstellar objects every year, identified early enough to permit rapid robotic flybys. Concepts under study at multiple space agencies outline launch-on-alert missions that could sample surface dust or even return grains to Earth. Each discovery thus acts as rehearsal for the day we chase one down in person. Whether the outcome is ordinary or transformative, the chase itself pushes instruments, sharpens global teamwork, and teaches the next generation to aim beyond yesterday's limits.
The legend of the Black Knight satellite tells us that a spaceship of extraterrestrial origin has been orbiting Earth for many years. Sounds crazy, right? But over the years, the supporters of the theory have gathered a lot of evidence to prove it. So let's look at it and judge for ourselves. 1899. Famous scientist Nikola Tesla built a giant tower in his laboratory in Colorado Springs. This tower was supposed to allow him to study atmospheric electricity and wireless energy. Everything went fine until one day he discovered something unexpected. The tower began to catch a signal that seemed to be artificial. At first, Tesla thought that the signal was coming from somewhere in the atmosphere, but it turned out that it had been coming from an even greater height, from outer space. Tesla decided that this signal was sent by some extraterrestrial life. However, the scientific community ignored his theory. Although they respected Tesla's genius, they still considered him to be a weirdo. But a few years later, Tesla's reports were confirmed. The inventor of the wireless radio, Guglielmo Marconi, intercepted similar signals. Then in 1927, Norwegian radio engineer Jørgen Machholz noticed something unusual. When he sent signals at a certain wavelength, they were sent back to him a few seconds later. At first, he thought it could be an ordinary radio echo. It's not uncommon for short radio waves to bounce between Earth and the stratosphere. This phenomenon is called propagation. But usually it happens very quickly, in about 1/7 of a second after the original transmission. However, the signals that Machholz received took about 15 seconds to get back. They also didn't match the radio echo people were used to. The engineer wasn't the only one to witness this phenomenon. Many radio enthusiasts discovered and confirmed these signals, but no one found any explanation. So what was it? Could Tesla have been right this whole time? Let's unpack this. First of all, the signals did exist, and they've been documented by many people. However, Tesla and Marconi's signals and Machholz's echoes are completely different things. In reality, Tesla and Marconi caught signals coming from pulsars. Pulsars are rapidly rotating neutron stars. Those get born when stars greater than our Sun finish their life cycle. After that, they become neutron stars and receive such a strong impulse that they begin to rotate at an insane speed. At the same time, the radio waves pulsars emit reach very far as our planet. Pulsars were discovered only in 1968, so it's not surprising that Tesla and Marconi couldn't explain the data they had received. But what about George Hall's? What he discovered is now known as LDEs, or long-delayed echoes. It's a more complicated concept because, to be honest, these echoes still remain a mystery. Scientists suggest that LDEs may be caused by something in Earth's atmosphere, or they might be reflected from the Sun's plasma clouds or even from the Moon. Unfortunately, we don't know the truth yet. The next incident took place in 1960. The New York Times published an article which said an unidentified silent satellite has been discovered circling Earth in a near-polar orbit by United States tracking stations. The identity and origin of the mysterious satellite, which has been dubbed the Dark Satellite, are unknown despite nearly 2 weeks of tracking. Many people believe that this must be the famous Black Knight satellite. However, later scientists confirmed that it was actually the remnants of a regular satellite that had gone astray. It malfunctioned and the thrusters sent it in the wrong direction, they claimed. Anyway, this whole story led to renewed interest in the Black Knight satellite. Astronomers all over the world started claiming to have observed it. Almost any strange celestial object could become the famous dark spaceship. But up to this point, all the photos and data about the Black Knight satellite have come from observatories on Earth. To prove or disprove its existence, people needed some witnesses in orbit. Gordon Cooper was a pilot and one of the first astronauts in human history. In 1963, he took part in the longest American space mission at that time, Mercury Atlas 9. During the flight, he discovered some strange green object, possibly of extraterrestrial origin, in front of his module. He then told his crew on Earth about that. NBC News picked up on the news and tried to interview Cooper about it, but strangely, neither NASA's mission transcripts nor Cooper seemed to give much importance to this fact, as if that didn't happen at all. Later, the official NASA's explanation was there was an electronic malfunction on Cooper's craft. It led to increased levels of carbon dioxide, which in turn caused Cooper to hallucinate. Cooper agreed with this version. Maybe it's just a curious coincidence that when he retired, he became interested in searching for extraterrestrial life. But even if we assume that all this is true and there is some mysterious spaceship in Earth's orbit, what do they want from us? Why would they be watching us? In 1973, Duncan Alasdair Lunan, a Scottish researcher, decided to investigate this. He gathered all the data on LDEs collected by Norwegian scientists and began to study it. Suddenly, he noticed some deviations that could hide a code. He arranged the data into a graph, where one axis meant the delay in time between the echoes, and the other the position of the echo in the sequence. It turned out to be a collection of dots which looked like some sort of space map, namely the map of the constellation Boötes. Lunan began to analyze the echoes recorded by French astronomers in 1929. Again, he got the same constellation, but one of the stars was in a slightly different place. Lunan then thought, what if it's actually a star map from the past? After rewinding the time, Lunan finally got the whole picture. He discovered that this was how the constellation looked 13,000 years ago, which probably meant that they could have been watching us for thousands of years. In 1973, Lunan gave an interview to the British magazine Spaceflight. He said that he had deciphered the radio message hidden in the LDEs. Here is what it said. Start here. Our home is Upsilon Boötes, which is a double star. We live on the 6th planet of 7 coming from the Sun, which is the larger of the two. Our 6th planet has 1 moon. Our 4th planet has 3. Our 1st and 3rd planets each have 1. Our probe is in the position of Arcturus known in our maps. Goosebumps. But even though these reports were published in the New York Times, Time, and other well-known magazines, no one really took this topic seriously. Unfortunately, Lunan's theory wasn't really backed up by any evidence. Later, he withdrew it himself, saying that he had made obvious mistakes and that his methods had been unscientific. According to him, he had just been making guesses about what these signals might mean. And finally, the last part of our story, this photo. On the 4th of December 1998, the Endeavour spacecraft embarked on the STS-88 mission. This was the first mission to the International Space Station. And then, on the 11th of December, NASA took and published a series of images where you could clearly see an unusual object in Earth's orbit. These photos were immediately picked up by the public. Everyone thought it was the Black Knight satellite, which had been discussed for years. Had it finally been found after 100 years of speculation? But as usual, the truth turned out to be much more boring. During the mission, one of the astronauts was installing a thermal cover, but the coating was poorly fixed. It broke off and flew away. The photos were taken just to document this event. The Black Knight is a very interesting legend. You can dig into it for hours, looking for new information and evidence, and then watch it getting debunked. This story is a pile-up of many completely unrelated stories, reports, photos of real satellites, and so on. All this was mixed into one incoherent, illogical urban legend. Illogical but very fascinating indeed.
A sound from space? When up there in space, no one can hear you talk, laugh, or scream. Or at least that's how the saying goes. People can't hear anything in space due to its condition. Still, if you have the right conditions, like the hot gas that surrounds the black hole located at the center of Perseus, space can be quite noisy. That's the galaxy cluster 250 million light-years away from us. Researchers caught an actual sound of space, waves rippling through the plasma gas in Perseus. They first realized black holes generate acoustic signals in 2003, but this is the first time they brought these signals to the human ear, and wow, this sounds terrifying. Canyons filled with liquid on Titan. Almost a decade ago, NASA spacecraft discovered deep canyons on one of Saturn's moons, Titan. They're about a half-mile wide and they kinda look like the Grand Canyon, but they're filled with liquid hydrocarbon. This was the first time we came upon evidence of canyons and channels filled with liquid on Titan. Our solar system is full of small particles and bigger rocks that circle the sun, the same way as planets. Sometimes it happens, some of them change trajectory, which is why falling pieces of debris strike the planets. Most of the meteorites and comets originate in our solar system. Some from the asteroid belt between Jupiter and Mars, while others come from the Kuiper belt, that's located beyond the orbit of Neptune. But 5 years ago, scientists found something unusual, a red, elongated floating space rock called Oumuamua. It could be more than 3,000 feet long, but its size still wasn't the most impressive part. It was the first interstellar object we saw passing through our solar system. It means it formed and came outside of it. It was traveling way faster than asteroids and comets from within our solar system. No one knows where this weird object came from. Many, many years ago, when it started its journey and sailed away from its parent planetary system, the stars weren't in the same position as they are today. So it's hard to pinpoint where Oumuamua ran away from. The rock could have been on its journey for billions of years. Solar termination events. Our sun is not just a flaming ball of gas we see in the sky. It's actually a pretty complex network of towering plasma fountains, magnetic fields, and blobs of unusual matter 500 times bigger than our own planet. And then there are solar termination events. When it comes to its activity, our sun goes through a natural cycle of troughs and peaks. Approximately every 11 years comes the time when the sun is more active than in other periods of the process. As the cycle goes to the end, there are fewer emissions and sunspots. That's because magnetic fields are weakened at that point, and they collide along the sun's equator. This results in enormous tsunamis of plasma. They pass across the solar surface for weeks. These are the most powerful storms in our solar system. They twist, snap, and lash out into space and seriously affect our power grid. As they wake, large spots start to form on the sun, close to strong magnetic field lines. Usually, that's when the cycle begins all over again. No one still knows why exactly they form. Also, we're not sure if this only happens at the end of the cycle, and knowing more about this could help us prepare for raging solar storms better. Tsunamis on Mars. It appears the shorelines under the Martian surface formed because of two enormous tsunamis. Mars has something that's probably the longest landslide in our entire solar system. The rocks rolled down the mountain probably billions of years ago. They fell into the water and caused a gigantic wave that rushed across the Martian landscape. As the tsunami was getting bigger, the rocks scraped all along the solid ground beneath them, and these sandy waves left their prints on the shoreline, not so close to Olympus Mons. That means it's possible the waves traveled a couple of hundred miles. This supports the theory that Mars once had an ocean hidden below its dry desert surface. Sure, Oumuamua was cool because it was the first object we've seen coming from outside of our solar system. It's past us now, so it's not possible to study it anymore. But something else came from outside our solar system after Oumuamua. A comet called Borisov. It came with a tail over 100,000 miles long. Teams got the first images of Borisov in 2019. A bright white glow was surrounding it. And that was one of the first signs where scientists realized this comet wasn't from our solar system. They tried to collect as much information as possible because they remembered how quickly Oumuamua got away. Borisov came from a freezing place as cold as the Kuiper Belt. One theory says it may have originated around a red dwarf, which is the most common type of star in our galaxy, the Milky Way. But unfortunately, Borisov was also very fast. So fast that they only managed to see it a couple of weeks before it passed by our planet. By now, it's almost out of our solar system. Finding new planets is always such a thrill, just like it was in 2017, when a group of researchers discovered Super Earth. It's an exoplanet, which means it orbits a star outside of our solar system. This one has a mass almost 3 times that of our planet, and it's only 21 light-years away. It orbits M-dwarf star, and it manages to make a full circle in only 2 weeks. So that's how long the year is on this planet. It's closer to its star than Mercury is to our sun. But M-dwarf stars are cooler than our sun, so it's possible this planet still has water. Super-Earth is generally a term for planets that are lighter than ice giants such as Uranus and Neptune, yet more massive than Earth. They can be made of rock, gas, or even a combination of both. The one they discovered in 2017 is especially interesting because this type of planet can also hold some form of life. Leroy Chiao is an astronaut who commanded the International Space Station back in 2005. This one time, during his final spacewalk, some pretty unusual lights caught his eye. It looked like 5 lights flying near him. They were in the shape of a pyramid, since one light was a bit further ahead. Chiao immediately called one of the crew members who was also out there at the same time, taking a spacewalk. He asked his colleague if he saw the flying objects, but apparently he didn't. Researchers were intrigued by this story, so they examined satellite images to see if that was the thing Chiao saw. One of the options was that Chiao had seen fishing boats off the coast of South America. With bright lights, they wanted to attract squid. But since it was twilight time, the rotation of our planet may have made them appear to fly by. Neutron stars slamming into each other. After a massive star comes to its end in a strong supernova explosion, its core falls apart. Then it forms the densest form of matter we know about in the whole universe, called a neutron star. In only a couple of the first few seconds after a regular star begins transforming into a neutron star, the energy there is equal to the total amount of light all stars in the universe emit. at least the part we can observe, which is still a lot. It's hard to determine their real size, but picture it this way: the length of Manhattan with 1.5 times the mass of the Sun. If a star here were any denser, it would just collapse and form a black hole. Scientists captured 2 of these stars colliding a couple of years ago, and such impacts are extremely powerful. They create gravitational waves that lead to a ripple in space-time, but they produce heavy elements like platinum and gold.
Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the Sun. Arguably one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P/Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these 3 occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Sheqi and Wenxian Thungkao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the Sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets, in general, may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small rocky space bodies also orbiting the Sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the Sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's comet appears to have formed in the Oort Cloud at the outer edges of the solar system. But Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs.
Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian. Or, that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort Cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort Cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort Cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space. Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is: an asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So, many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kinda like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet, so it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So, the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. and we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small, non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. But it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth. Recently, Voyager 1, a space probe designed to study the outer solar system and interstellar space, started sending truly bizarre messages to Earth. It was impossible to decipher them. Scientists were perplexed. Were extraterrestrial civilizations trying to tell us something? It turned out not to be the case. Apparently, the spaceship has encountered serious problems on its space voyage. Currently, NASA is trying to reach across 15 billion miles to rescue the probe. Unfortunately, spacecraft can't live forever. Last year, Voyager 1 started beaming home total nonsense. And if before it was a string of binary code consisting of ones and zeros, now it's something unintelligible. It means that billions of miles away from home, beyond the protective bubble surrounding the solar system, Voyager 1 is in big trouble. The Voyager 1 team on Earth traced the problem to the probe's flight data system. It's an onboard computer parsing and parceling all kinds of science measurements for further radio transmittal to Earth. One theory claims that it could have been struck by a high-energy cosmic particle, which caused problems with the system's memory, like a bit flip. Bit flips occur when you're copying data, and one of the bits changes, making everything incorrect. A value of 1 becomes a 0, or vice versa. Usually the team simply asked the spacecraft for a memory readout. It allowed them to find and reset the errant bit. But this time, they don't know where the bit flip is because they can't see what the probe's memory is. And it's the most serious issue they've had in a long time. It's very worrying because they've lost communication with the spacecraft. But recently, the team has managed to break through to Voyager 1. After months of stress and failed attempts, they finally managed to decode a portion of the spacecraft's gibberish. This might allow them to find a way to decipher whatever it's trying to say. While you're watching this video, Voyager 1 has already traveled around 10,000 miles of almost empty space. Voyager 1 and its sibling, Voyager 2, are slipping away from us at incredible speeds. Sooner or later, they're bound to fall silent. The Voyagers are very important to humanity, as much as they're beloved. The Voyager missions were supposed to exploit a once-in-175-year alignment of Jupiter, Saturn, Uranus, and Neptune to slingshot through our solar system, exploring its most distant regions. Outfitted with nuclear power sources, these space probes were built to last. Nearly half a century later, the probes are still the farthest flung and longest-lived missions ever sent into the cosmos by people. Voyager 1 is the front-runner, and its sibling is trailing close behind. In the years 1979 to 1981, the Voyagers zipped by the gas giants of our solar system, sending stunning images of Jupiter and Saturn, as well as their collection of moons, to Earth. Voyager 2 then went on to explore the ice giants, Uranus and Neptune. Those were actually the first and so far only times people had seen those bluish worlds up close. After that, the Voyagers left the realm of the known planets. Each of them followed its own path into darkness. Voyager 1 moved up and out of the plane of the solar system, while Voyager 2 looped downward. As the Voyagers traveled farther from Earth, the team switched off many onboard instruments, including the cameras. But the spacecraft kept studying the space they were flying through. Their main task was to examine the heliosphere, that protective bubble around our solar system formed by the sun's wind and magnetic field. It blocks cosmic rays, protecting us from space radiation. The Voyagers were supposed to document the unfamiliar mix of particles and fields, escape the solar system, and turn into real interstellar wanderers. It happened in 2012. Voyager 1 crossed the boundary where the sun's influence waned, and if before we could only make guesses about what was beyond that barrier and how it shielded Earth from the harshness of the cosmos, now Voyager 1 could tell us directly about the stuff filling space between stars. Voyager 2 followed its sibling in 2018. Many different things have nothing in common at first glance. The appearance of mysterious clouds over Stonehenge and the migration of wolves in Canada, patterns on the wings of a Caribbean butterfly, and strange footprints on the moon's surface. These are all random facts, but people can see connections in these events. Let's see how it can happen and where it can lead to. Imagine reading some crazy article on one of the unreliable sites, forgetting about it, and then beginning to notice small details in the world that might indicate that the information in this article is true. You realize you've learned something unusual, but for some reason, other people don't see it or don't want to see it. You try to tell them, but no one wants to listen to you. And some people even think you've gone mad. Let's stop for a moment and see what kind of article you've read. So, in 2017, one not-so-truthful site published a story about a ship from another planet called Black Knight that had been spying on people for 12,000 years. But not long ago, agents from a secret organization managed to destroy it. Sounds like absolute nonsense or a plot for a cheap sci-fi movie. Of course, you don't believe it. But a few years later, you find a story about Nikola Tesla. Let's fast forward to 1899. The famous scientist was sitting in his laboratory in Colorado Springs conducting radio experiments. Suddenly, his receiver caught a strange radio signal. Then, after a while, another one. The signals came in with the same time interval, as if someone wanted to send a message. Nikola Tesla realized it could be something from extraterrestrial civilizations that were trying to start a dialogue with people using the most universal language, math. He also reported about this event in a magazine at the beginning of the 20th century and added that he hadn't deciphered the message. Okay, now let's forget about it and see what happened next. In 1927, an engineer from Oslo, who was fond of radio devices, was sending signals into open space. He was surprised when, sometime later, the same signals began to return to his receiver. It was as if the signals bounced off something big and echoed back, or something received these messages and then sent them back to the sender to make an acquaintance. The man quickly reported his discovery to scientific journals, and perhaps someone connected this event with Nikola Tesla's words about strange signals from space. All this were just prerequisites for the Black Knight. But the most exciting events started decades later. In the 60s, Time magazine published an article that said that the U.S. had discovered a satellite orbiting Earth and using unknown technology. A couple of years later, Project Mercury astronaut Gordon Cooper reported that he had seen a strange object during his spaceflight. But the Black Knight became really famous only in the late 90s when NASA published a series of images of a mysterious object. During the first flight to the ISS, astronauts noted weirdly shaped somethings and took several pictures. Then someone gathered all the facts, collected all the information about the black satellite, and discovered that it had been flying around our planet for more than 10,000 years. How did they figure it out? People managed to calculate the age of those radio signals that Tesla and the engineer had received. If this is true, The black night appeared much earlier than the Sumerians in ancient Egypt. What if this satellite helped build pyramids and majestic temples? What if it had been watching over our development all this time and transmitting this information to another planet? What if mysterious images ancient people drew depicted the satellite? People began to suspect NASA and other space agencies of hiding information about the black object to prevent panic. And now, after having received all the data about the mysterious satellite, you might begin to suspect that the bizarre article may actually be true. This news is so improbable and ridiculous that no one will believe it. If you want to hide something, hide it in plain sight. And so, together with other enthusiasts, you start hunting for any information about the mysterious ship. You create forums, post photos of unknown objects, and become obsessed with this topic. You really believe in the reality of the Black Night. Moreover, you don't want to question its existence, and people reading your articles do the same. Congratulations! You have become an ideal candidate for creating fake news in the yellow press. Such myths and urban legends seem attractive. The human brain feels pleasure when it finds fake secret information. The feeling of mystery, adrenaline, and shock can cause psychological addiction. That's why the stories about the Black Night are still alive. Mysterious facts seem logical, and people stop seeing information that refutes their theories. The case of the Black Night is no exception. The fans of this black object believe that Nikola Tesla received signals from some space civilization. But for some reason, they don't attach importance to scientific articles, which say that such radio signals could be sent by giant space objects like pulsars. A pulsar is a rotating neutron star emitting powerful electromagnetic radiation. Such radiation is often found in space. These radio waves don't imply the presence of a mind and a sender. The cosmos is full of such signals. The technology for detecting such objects were created in the 60s. Or maybe Tesla's device caught a signal coming from our planet. Besides, the scientists didn't see anything about the Black Night. So why did people connect these two events? That story with the Norwegian engineer is still unexplained. Yes, his signals returned as an echo, but this had nothing to do with the flying object in question either. You might as well say that the satellite somehow influenced the Titanic. There's no logic in such assumptions. Strangely, no one connected the Black Night with the Yeti or the Kraken. Now, let's return to that Times article about a strange object flying around Earth. It also stated it was a fragment of an American reconnaissance satellite. But fans of myths and legends apparently didn't notice this explanation. As for astronaut Cooper, who is said to spot some object during his mission, he actually saw nothing. He even showed a transcript with no reports about the black satellite. However, some believers in other civilizations keep silent about this fact. So, the main proof of the Black Night's existence is the photos taken during the first flight to the ISS. The astronauts noticed this strange object and took pictures, but it wasn't a surprise for them because some part of the ship broke away during some work they did outside. It was a piece of thermal coating. The astronauts sent the photo to NASA, and the space agency assigned it a personal number, as it does with all such objects. A few days later, the Black Night fell out of orbit and burned up in Earth's atmosphere. Almost all this information was recorded in official protocols. One of NASA's engineers, who knew the photographer of the black satellite, explained that those famous photos depicted an ordinary piece of the ship. There was nothing fantastic about it. But the fans of extraterrestrial rockets must have missed all this information. All these myths have long been debunked, and all the false facts have been refuted. But the Black Night continues to live in many people's minds and on the pages of the yellow press. It has become a link between many reports of strange flying objects. Over the years, hundreds of stories have appeared about secret laboratories with extraterrestrial technologies, about NASA hiding secrets, and about creatures from other planets. And many people connected these myths with the black satellite. It has stopped being a real physical object. Now it's a cultural phenomenon. Remember how the main symbol of extraterrestrial civilizations was a flying saucer? It's not trending anymore. Today, the symbol is a black, weirdly shaped stone. Don't be fooled.
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner, or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, One solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the sun heating up and getting denser. As a result, the sun would get way larger than it is now. During this transformation, the sun would swallow Venus, Mercury, and Earth.